By 0347 local time, the duty operator at the relay station had been staring at the same screen for 6 hours. Nothing moved. The sector was quiet. A warm July night in occupied Zaporizhia Oblast, and the integrated air picture looked clean. 3 S-400 batteries, all networked, all reporting green. The operator reached for his coffee. He did not reach it. The first anomaly was not an explosion. It was silence. A gap in the data link feed. A flickering dropout in the command channel that lasted less than a second. He logged it as atmospheric interference. He had seen it before. He would not see it again. 4 seconds later, the relay node ceased to exist. And in that same instant, without a single missile being fired at them, 3 S-400 Triumf batteries in the southern sector went blind. What happened in the next 90 minutes over southern Ukraine in early July 2026 was not a conventional air defense attrition strike. Ukraine did not spend a single expensive missile hunting down a launcher. It did not target the radars. It did not go after the transporter erector vehicles or the command posts. It went after something smaller, something most analysts had not even placed on the target list. And when it fell, it took down 3 batteries simultaneously, opening a corridor through Russia's most layered air defense architecture in the south. Stay with this, because what came through that corridor is the part that changes how you understand the next phase of this war. Let us go back to the beginning. Not the night of the strike, but the weeks before it. Because this operation did not start with a missile. It started with a headset, a spectrum analyzer, and an antenna array pointed at the sky. Ukraine's Military Intelligence Directorate, the HUR, had been running a signals collection campaign across occupied southern Ukraine since late spring 2026. The target was not the S-400 launchers themselves. Those are obvious. They are large, they move occasionally, and they have been cataloged by satellite imagery since the early weeks of the full-scale invasion. Every major Western intelligence service knows roughly where they are. Striking them directly is possible but expensive. An S-400 launcher costs Russia approximately $500 million. Replacing one takes years. But hunting them with precision cruise missiles is a consumption contest Ukraine cannot sustain indefinitely. So Ukraine's targeting analysts asked a different question. Not where are the batteries, but what makes them a network? The S-400 Triumf is not simply a missile launcher. It is a node in an integrated air defense architecture. A single S-400 battery consists of the 91 N6E acquisition radar, which tracks targets at ranges up to 600 kilometers. The 92 N6E multifunction engagement radar, which guides missiles in the terminal phase, the command and control vehicle, and the launchers themselves, typically 8 transporter erector launchers per battery, each carrying 4 missiles ready to fire. That is a formidable single unit. But its real power comes from integration. When 3 batteries share a common data link, passing track data, assigning engagement sectors, deconflicting targets, they function not as 3 separate systems, but as one distributed sensor-shooter network with triple the coverage and triple the firepower. That network depends on something unglamorous. It depends on relay infrastructure, radio relay towers, data link repeater stations, command channel transceivers, the connective tissue that lets Battery 1 in Tokmak see what Battery 2 in Melitopol is tracking, and hand off an engagement to Battery 3 near Berdyansk without a single voice call being made. Remove a launcher, and Russia loses 1 firing unit. Remove the relay node and Russia loses the network. 3 batteries become 3 isolated, uncoordinated systems, each operating on its own radar picture, unable to share track data, unable to deconflict, unable to coordinate sector handoffs. That is the target Ukraine spent weeks looking for, and Ukraine found it by listening. The HERS electronic warfare collection units, operating from positions inside Ukrainian-controlled territory and, according to reporting, from assets closer to the contact line, spent approximately 6 weeks in May and June 2026 mapping the radio frequency environment across the S-400 operational zone in southern occupied Ukraine. The S-400's data link and command systems operate in specific frequency bands. The 9S52M Pollyanna D4M1 automated command system that coordinates multi-battery S-400 operations uses encrypted data link signals in the centimetric waveband, but those signals still have a physical signature. They emit, they can be detected, and if you detect the same emission from multiple positions and measure the angle of arrival precisely enough, you can triangulate the source. This is direction finding. It is not new technology, but doing it against a carefully managed, frequency-agile military communication system at distances of 40 to 80 kilometers across a contested electromagnetic environment saturated with jamming is genuinely difficult work. Ukraine's teams did it over 6 weeks. They identified not just the existence of a relay node, but its precise position, within meters, and they passed those coordinates to a strike cell. Now here is the question that should be sitting in the back of your mind, because it is the same question the Russian air defense operators in that sector would ask themselves in the hours after the strike. If Ukraine had the coordinates of this relay node, why did it take 6 weeks? Why not strike it the moment it was found? The answer tells you everything about how this operation was actually planned. Striking a relay node that the Russians know you have found achieves very little. They shut down the node, move the equipment, bring up a backup, and reroute the data link through alternate paths within hours. The S-400 system was designed with redundancy, specifically because its operators know that command and control infrastructure is a high-value target. A premature strike buys Ukraine perhaps 12 hours of degradation before the network reconstitutes. Ukraine needed the strike to be simultaneous with something. It needed to exploit the window, not create it in isolation. The relay node was not the mission. The relay node was the key. What mattered was what came through the door once it was unlocked. So for 6 weeks, while Ukrainian signals intelligence teams refined the coordinates and confirmed the relay's continued operation, a separate planning cell was preparing the follow-on wave. A drone package. Multiple systems, multiple approach vectors, timed to arrive over their targets in the southern sector within the window created by the relay's destruction. Not days later, not hours later, minutes later. The relay would fall, 3 batteries would go dark, and before their crews could manually coordinate or fall back to VoiceNet procedures, the drone wave would be inside the engagement zone. Let us talk about the relay station itself, because understanding what it was physically explains why destroying it was both relatively straightforward and strategically decisive. Relay nodes in a military data link network are not always exotic hardened facilities. In the S-400's operational deployment across occupied southern Ukraine, the connective infrastructure has included, according to satellite imagery analysis published by open-source intelligence groups in 2025 and 2026, a combination of purpose-built military relay vehicles, semi-permanent mast installations at elevated terrain features, and in some cases civilian telecommunications infrastructure adapted for military use. The node struck in this operation was assessed by Ukrainian military sources cited in subsequent reporting as a semi-permanent installation, a military relay mast on a low-rise south of Tokmak, supported by a generator unit and a small equipment shelter. Not a bunker. Not a hardened facility. A structure that was militarily significant, precisely because of its position in the data link topology, not because of its physical resilience. It was struck, according to Ukrainian military reporting, by a precision munition. The specific system has not been officially confirmed, though reporting from Ukrainian defense journalists in the week following the strike cited a domestically produced guided missile in the Neptune family of precision weapons. Ukraine did not confirm or deny this specifically. What Ukraine did confirm was the effect. The relay node was destroyed in a single strike, and the resulting gap in coverage was assessed as lasting between 40 and 70 minutes before Russian forces could establish alternate routing. 40 to 70 minutes. That is the window. Now put yourself in the position of the battery commander at the southernmost S-400 unit in the affected sector. It is 0347 in the morning. Your data link drops. Your integrated air picture, the shared track file that tells you what the other 2 batteries are seeing, what is inbound from the east, What is crossing from the Black Sea direction goes blank. You have your own radar. The 92N6E is still running. You can see what is in your own engagement volume. But you cannot see what Battery 1 to your north is tracking. You do not know if what you are seeing is the entire threat picture or a fraction of it. You go to VoiceNet. You start making calls. Your sector coordinator is trying to reconstruct the air picture from 3 separate voice reports simultaneously. It is slow. It is confused. And it is in this window of confusion that the drone wave arrives. Ukrainian drone operations over occupied southern Ukraine in mid-2026 had grown considerably more sophisticated than the early kamikaze swarm tactics of 2022 and 2023. The packages used in this follow-on wave combine several categories of system. Long-range fixed-wing strike drones in the class of Ukraine's domestically produced Lyuchi and Bober airframes, with operational ranges exceeding 1,000 kilometers, formed the primary strike element. These aircraft-shaped drones fly at altitudes between 50 and 300 meters, depending on terrain masking, move at speeds of 150 to 200 kilometers per hour, and carry warheads in the 20 to 70 kilogram range. They are not fast. Against a fully operational S-400 battery with complete situational awareness and a clean track picture, a slow fixed-wing drone at low altitude is trackable, engageable. It dies. Against a battery operating in manual coordination mode, with a degraded common air picture, managing VoiceNet deconfliction across a disrupted sector, while simultaneously trying to track a multi-axis threat package, the equation changes. The drone wave entered the degraded sector from 2 general approach directions. One element approached from the northwest, using the terrain of the Dnipro River Valley for radar masking. A second element came in lower from the west, keeping its altitude below 50 meters for as long as possible before the final approach geometry forced it higher. Both elements were tracked by individual batteries, but without the shared track file, neither battery had confidence in whether the other was already engaging the same targets. Engagement authority was confused. The sector coordination that normally happens automatically through the Pollyanna data link system was now happening through shouted voice reports between operators trying to rebuild a picture from scratch. 2 of the primary targets in the follow-on wave were reached and struck. Ukrainian military reporting in the days after the operation cited damage to a logistics facility near Tokmak and what was described as a significant strike on a field fuel and ammunition point supporting Russian ground forces in the Zaporizhia axis. The S-400 batteries in the affected sector did engage. They fired. Russian defense reporting in the immediate aftermath claimed interceptions. Independent verification of those claims from satellite imagery was incomplete at the time of this report. What satellite imagery did show, confirmed by several open-source analysts in the days following, was damage consistent with successful strikes on at least one of the designated targets. The relay node itself was confirmed destroyed. That much was not disputed. And now we come to the part that matters most. Not what burned, but what this means for the next 6 months of this war. Russia's air defense architecture in occupied southern Ukraine is not infinite. It is dense by any conventional measure. The concentration of S-400, S-300 V4, and Buk M3 systems in the Zaporizhia and Kherson oblasts represents one of the highest densities of surface-to-air missile coverage anywhere in the world. Russia has prioritized this belt because it understands what Ukraine needs to do: suppress air defenses sufficiently to allow its own aircraft, missiles, and long-range drones to operate with greater freedom over the southern axis, where the territorial stakes, the land bridge to Crimea, the port of Berdyansk, the logistics corridors feeding Russian forces on the eastern front, are at their highest. But density creates its own vulnerabilities. A dense air defense network is a dense communications network. Every battery needs data link. Every cluster of batteries needs relay infrastructure. The more batteries you field, the more relay nodes you need. And relay nodes, unlike launchers, are not on anyone's most watched target list. They do not show up in the dramatic footage of launcher vehicles burning. They are mundane. A mast, a shelter, a generator. They are unglamorous enough that their loss often does not make the headline, but their function is irreplaceable. What Ukraine demonstrated in this operation was a targeting methodology, not just a one-time strike. The signals collection process that identified this relay node can be applied across the entire southern air defense belt. Every S-400 cluster that networks its batteries through relay infrastructure has, by definition, a relay node. Finding those nodes takes time and skill. Ukraine has now demonstrated it has both. The implication for Russia's air defense planners is uncomfortable. The network's strength is also the network's liability. The more integrated the air defense picture, the more valuable and the more targetable the infrastructure that creates that integration becomes. Russia will adapt. It always does. Backup routing, more frequent node displacement, tighter emissions discipline. These are the countermeasures that will follow. But each countermeasure carries a cost. Frequent displacement of relay infrastructure degrades the reliability of the data link. Tighter emissions discipline means shorter transmission windows and less complete shared track data. The network becomes less integrated as it tries to protect itself. Ukraine does not need to destroy the entire relay infrastructure to degrade southern air defense effectiveness. It needs to make Russia's operators uncertain. Uncertain about whether their coordination is reliable. Uncertain about whether the node they are routing through has been found. Uncertain enough to operate more conservatively, to hold fire longer, to double-check voice net confirmations before engaging. Uncertainty is the second-order effect, and in air defense, uncertainty costs lives and loses engagements. There is a strategic context for this operation that sits above the tactical details of one relay node and one drone wave. Ukraine's military command, since the beginning of 2026, has been executing a deliberate campaign of air defense suppression that prioritizes network disruption over platform destruction. This represents a significant evolution from the strike patterns of 2023 and 2024, when Ukraine's long-range strikes were heavily weighted toward logistics infrastructure, fuel depots, ammunition stores, rail junctions. Those strikes remain part of the campaign. But the targeting logic has expanded to include the command and control layer of Russia's military machine in the occupied territories. Not just what Russia uses to fight, but how Russia coordinates the fight. That shift reflects a harder targeting intelligence capability, the ability to map not just physical infrastructure, but network topology. Where is the command post? Where is the relay? Where is the fiber trunk or the radio bridge that carries traffic between them? These are questions that require sustained signals collection, human intelligence, and analytical capacity. The HER has been building that capacity for 2 years. This strike was one of its most visible applications. The S-400 batteries in the affected sector were not destroyed. They are still there. Russia will repair its relay network. The integrated air picture will come back online, probably within days. But Ukraine has demonstrated to every Russian air defense commander in the south that the connective tissue of their network is not invisible. It has been mapped, it can be struck, and the next time, they will not know which node has been found and which has not. That is not a tactical problem. That is a cognitive one. Watch for 2 developments in the weeks following this operation. The first is Russian countermeasure activity, increased movement of relay vehicles, changes in emission patterns, possible introduction of additional backup routing through fiber or encrypted satellite relay to reduce the radio frequency signature that allowed Ukraine's direction-finding teams to locate the node. Satellite imagery of the affected sector showing new vehicle concentrations at elevated terrain features would be consistent with relay infrastructure displacement. The second is what Ukraine does with the methodology it has now validated at operational scale. If the signals collection and precision strike pipeline that identified and destroyed this relay node is exportable across the southern sector, and there is no technical reason it cannot be, then the targeting queue for S-400 relay infrastructure in occupied Zaporizhia, Kherson, and the approaches to Crimea has just gotten longer. A sustained campaign against relay nodes, spaced to deny Russia time to fully reconstitute before the next strike, would impose a compounding degradation on the integrated air picture across the entire southern belt. That degradation, in turn, would open more windows for Ukrainian strike assets. Not just drones, longer-range munitions, potentially, eventually, aircraft operating with greater confidence in a suppressed air defense environment. The logic compounds. Each window opened makes the next strike more achievable. Russia knows this. The speed with which it reconstitutes and hardens its relay infrastructure in the coming weeks will tell you how seriously Moscow's air defense commanders are taking the lesson. Watch the satellite imagery. Watch the emissions environment. The answer will be there. If you want to understand this war as it unfolds, not the noise, not the headlines, but the strategy underneath them, the targeting logic, the systems, and the decisions that actually determine what happens next on the map, subscribe to this channel and turn on notifications so you are there the moment the next chapter breaks. Hit the bell. Every strike we cover, we break down the same way. The system that was targeted, the reason it mattered, and what it means for the weeks ahead. That is the work. And one final note for the record. This report is news analysis and reconstruction of ongoing, fast-moving events, built on reporting from major outlets, open-source intelligence analysis, and grounded in the facts as they are known at the time of writing. As the situation develops, details will change. Some elements of any reconstruction involve reasonable inference about systems and procedures that are not publicly confirmed in full detail. Stay sharp, stay informed, and we will see you in the next one.